Welcome new viewers and old subscribers, those that have been following this tutorial and those that are just joining and watching this video for the first time, you're welcome. Today's class we are going to look at Newton's second law of motion, momentum, impulse of a force. Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the applied force.
Rate of change of momentum of a body. This is for momentum, final momentum, initial momentum. Then the time, remember when we talk about rate in physics, we deal with time. So the rate of momentum of a body is directly proportional to the applied force.
Momentum is the product of mass and velocity. Mass in kg, velocity in meter per second. Therefore, the SI unit of momentum is kilogram meter per second.
We can use P as the symbol for momentum. Momentum is the product of mass and velocity. If mass is in kg and velocity is in meter per second, so this is the SI unit of momentum. We are going to derive another SI unit of momentum as, so we can say is this all Newton seconds. So let's show that of Newton seconds using the second law of motion. That's Newton's second law of motion.
Please remember to hit the subscribe button, like this video, share this video to your friends, invite others. So let them come and join us so that I'll be encouraged to do more. The more the number, the more I'll be encouraged to do more. So let's invite more people. Impulse of a force is the product of force and time. F times T. Impulse of a force is the product of force and time.
Then the final momentum be the product of mass and final velocity v. So we have the change in momentum. The change in momentum will be equal to mv minus mu. That's initial momentum minus final momentum. This is the change in momentum. This is the rate of change of momentum. And we are saying that this rate of change of momentum of a body is directly proportional to the applied force. So the rate of change of momentum is directly proportional to the applied force. If we change it to equal to sign and have mv minus mu over t, remember force times t, we have force times time is equal to the rate of change of momentum. So this mv minus mu is the change of momentum of a body, and ft is called the impulse of the force. Impulse of a force, that's the product of force and time, is equal to the change in momentum. F is in Newton, time is in seconds. That's why the SI unit of impulse is Newton seconds. I can choose to rewrite the equation like this. I just factored out the mass m and then have v minus u in bracket. So from this, F is our force, then mass is m. You know that this is v minus u over t is acceleration, because v minus u is change in velocity over time. So acceleration is change in velocity over time. This Newton's second law of motion, this is also the proof that F is equal to ma. So don't forget Newton's second law of motion, which states that the rate of change of momentum of a body is directly proportional to the applied force. Please don't get distracted. Watch this video to the end. Let's go to calculation examples. Please remember to subscribe, like this video, drop your comments so that YouTube will favor this video and push it more to other people. The more viewers I get, I'll be encouraged to do more. Okay, let's take the first example. A body of mass 2 kg moving vertically upwards has its velocity increased uniformly from 10 meters per second to 40 meters per second in 4 seconds. Neglecting air resistance, calculate the upward vertical force acting on the body. G is given as 10 meters per second square. This is from JAMB 1997. So let's solve this together. Step 1. Write out all the parameters you're given. A body of mass 2 kg. So we have the mass. M is given as 2 kg. Please write out everything you're given. Then the velocity. The final velocity V is given as 40 meters per second. And the initial velocity U is given as 10 meters per second. How do you know the final and initial velocity? Remember, it's moving from 10 meters per second to 40 meters per second. And time is given as 4 seconds. So the initial one is 10, then the final velocity is 40. Neglecting air resistance, calculate the force. We are looking for the force. So now, the first step is to write out all the parameters you're giving and then identify what you are looking for. The unknown is F. That's what we are looking for. You put question mark. Based on the things we are giving and what we are asked to find, we are looking for force, F. So which formula are we going to use based on all the parameters we are given? So we are going to use this. Mass is given, V is given, U is given, and time is given. So that's what we are going to apply. Mass is 2, the velocity is 40, in final velocity minus initial velocity over the time. So please learn how to solve without calculator. Learn how to solve without calculator. Remember, it's CBT. In this case, 2 here is 1, 2 here is 2. Then 40 minus 10 will give us 30. 30 over 2, the final answer we are going to have is 15. Remember the units, Newton. The number 2 example is from JAMB 1999. Two bodies have masses in the ratio 3:1. The experienced forces which impact to them accelerations in the ratio 2:9 respectively. Find the ratio of the forces the masses experience. So let's look at all the parameters so that we'll know what we are expected to look for. So we have two cases. The first case, let me call this one the first body and call the second one the second body. So these are the two bodies. The mass for the first body is 3 and the mass for the second one is 1. So mass is given. Let me draw this line so that it will be better. For mass, M here is 3. Remember, masses are in the ratio 3:1 and M here is 1. Then the experienced forces which impact to them accelerations in the ratio. So acceleration A in the ratio 2:9. So the first one here we have 2A and we have here as 9A. Find the ratio of the forces the masses experience. So what are we looking for here? Let's call this one F1 and call this one F2. So it's forces that we are looking for. Since we are looking for the ratio of the forces, for the first body, we are going to say force is the product of mass times acceleration. So this mass 3m times the acceleration is 2a. Then for the second body, the mass is 1, that's the mass, and the acceleration is 9a. So force for the first body is, we are going to have it to be 6, then mass and acceleration. For the second body, we are going to have it to be 9, then mass and acceleration. So since we are looking for the ratio, the ratio of the force for the first body, which is 6 ma over that of the second body, 9 ma. So a will cancel a, m will cancel m. 2 here, okay, 3 here will give us 2, and 3 here will give us 3. So our final answer will be 2 over 3, which is 2:3. The correct option, you now check for the correct option, which is option C. Please, after watching this, you can click on the video that will be suggested to you to watch the full video on linear momentum, impulse momentum, and more.